Alright, hey everybody, so this video is going to be our last video going over Unit 3 skills. So when we're talking about acids and bases, and we're talking about whether or not it's going to be a strong acid or a strong base or a weak acid or base, the best way to determine whether or not it's going to be strong or weak is through percent dissociation. And percent dissociation measures the total or the percentage of total molecules in the solution that have dissociated or broken apart into their ions. Okay, so typically when you have a ionic compound, you have a cation, which is positive, and an anion, which is negative, and they break apart in water. And so we learned about that in Unit 2 with solutions, dissociation. And so the more molecules that dissociate, the stronger the solution is. So when we're looking at these pictures, just as a key, typically we draw atoms that are still together as being not dissociated. They're not broken apart, whereas when the ion atoms are separated and now they typically also have a charge written, whereas together they don't, these are dissociated or broken apart. And so the more you see of this, the stronger it will be. Because remember, acids are measured based on their H+. Key thing being there is that charge, which means it needs to be separated. So when we look at this first question, it doesn't tell us whether it's an acid or a base, but we can figure out whether or not it's strong or weak by looking at the molecules. So we see here that these molecules are still together, so we can label this as being weak. And we can see here that all of these molecules are broken apart, so we can say it's strong. Now, remember, we always have to explain, especially on our final exam. That is your last chance to show that you have learned things. So you want to explain things in a lot of detail. So we would say that it's strong because all of the molecules have dissociated. Okay, and you want to use that vocabulary word. You could also say they have broken up, just like you could say the other one is weak because the molecules have not dissociated, right? But you want to always explain why you have decided that something is strong or weak. Now, if we look at this next section, okay, you can also identify whether or not a solution is strong or weak based on the pH. However, pH, this is not the best way to do that. It's not always accurate, okay? So it is not always correct. But if that's all you have, then you can make a good guess. Now, pH stands for potential hydrogen, okay? So the H in pH is capitalized because it's the capital letter H for hydrogen, the symbol from the periodic table. And it measures the amount of hydrogen ions that are in the solution. And acids have a pH that are less than 7, which means that there are a large number of H+ molecules. Bases have a pH more than 7, which means that there are a few or small number of H+ molecules. Now, this is what I said earlier, but pH is not always an accurate measure of strength, which actually I wrote strength twice, so there's no need for this blank. But it will always tell you if a solution is an acid or a base, okay? And if you can only see the pH, like they don't tell you the percent dissociation, then the closer the number is to 7, the weaker it is, okay? And so if you're given both pH and percent dissociation, you should always use the percent dissociation to determine the strength. So if you need to use pH though, so remember, pH scale goes from about 0 to 14, You have acids that are less than 7, bases that are higher than 7. And so anything from maybe about 4 to 7 would be considered weak, and maybe about 10 to 7, that would be a weak base. And then you have strong on the ends. But again, pH, I'm going to put this over here again. pH is a guess at strength. All right? It will for sure tell you if it is an acid or a base, but strength is only a guess. So if you're only given this information, that the solution has a pH of 2, then you can make a guess that it is a strong acid because it is close to 0, right? Or, for example, solution with a pH of 8. 8 is higher than 7, so you know for sure it's a base, but since it's so close to 7, we could say that this is a weak base because it is close to 7 and higher, right? And we might want to add that to A. So we know it's a strong acid because it's close to 0 and below 7, right? The being below 7 is how you know it's an acid. And you can do that for C and D as well. So you should be able to identify that solution C, a 5, it's less than 7, so we know it's an acid. It's pretty close to 7 compared to 0, so we can make a guess that it's a weak acid. And a solution with a pH of 13, it's higher than 7, it's pretty close to 14, so we can make a guess that this is a strong base. And so if you're only given pH, you can solve it that way. However, if we look at this combination question, it says label each solution as either a strong acid, a strong base, a weak acid, or weak base, and explain why. So when you're going through this, okay, each solution gives you pH and percent dissociation based on the picture. So remember, we always are going to use pH to tell us if it's an acid or base, and then you need to use percent dissociation to determine if it's strong or weak when you're given both information, both pieces. So we can go through and, label. So pH 6.5, that's less than 7. So this is an acid because pH is less than 7. Okay, solution B, pH of 13. This is a base because the pH is greater than 7. Solution C, pH of 2. This is an acid because pH is less than 7. And solution D has a pH of 8, so that's a base because the pH is greater than 7. So this we know for sure, but strength we can only make a guess. Now, if we look at solution A carefully, we see that all of the molecules are still together, which means this is a weak solution. And if we had guessed that based on our pH, because it's so close to 7, our guess would have been correct. So we say that this is a weak, or we say it's weak because they're not dissociated, because it is not dissociated. If we look at solution B, it's a strong base, we see, but it's strong not because the pH is 13. That's only a guess. That confirms that our solution, they've broken apart. So it's strong because 100% or all of the molecules dissociated. That is what makes it strong. Okay, so they all dissociated. Now, if we look at solution C, a pH of 2 makes you think that it's strong. However, notice only one molecule dissociated. So even though it has a pH of 2, this is actually weak because only one of 4 molecules dissociated. That would be 25%. That's not a lot, okay? And if we look at solution D, we see a pH of 8. You would think that that would be a weak base, but look, every single molecule has broken apart. So this is actually strong because all the molecules dissociated. So you have to break it up and use both pieces of information. If you have a question on your final exam that gives you the dissociation and the pH, you need to use both of them in your explanation or you will not get full credit. So you want to make sure to review those. So in the next video, we'll start on Unit 4, but hopefully this helps clear up some questions you might have had about acids and bases.